Geometry, section 2.3, deductive reasoning, the law of syllogism, and the law of detachment. Other way around, actually, law of detachment and law of syllogism. Okay, going to be doing some bouncing around here. I'm getting better at this video making stuff. I had never thought before that I should copy things out of the online book, but finally thought of it. And we're going to be using deductive reasoning, and there's a definition for you, but basically deductive reasoning is the reasoning that you're using when you're using the two laws of this section, the law of detachment and the law of syllogism. Okay, now first let's look at an example. Just use logic here. A gardener knows that if it rains, the garden will be watered. True statement, right? If it rains, the garden will be watered. It is raining. Okay, so a simple statement of fact. A gardener knows that if it rains, the garden will be watered is a conditional statement, but then a simple statement of fact, it is raining. Basically, you're being told in a conditional statement, if hypothesis, then conclusion, that the hypothesis is true. If it rains, then the garden will be watered. It is raining. The hypothesis is true. What you can conclude then is that the conclusion is true. If hypothesis, then conclusion, the conclusion here is the garden will be watered. You can conclude that that is true. You can conclude that the garden will be watered. Logical, right? Makes sense. Should make sense. Okay, now, with that, look back here at the first quick check down here. Suppose that a mechanic begins work on a car and finds the car will not start. Can the mechanic conclude that the car has a dead battery? Okay, again, logical. No, the mechanic cannot conclude that the car has a dead battery because many students will say, well, because there are other reasons why a car will not start, right? It could be that the ignition is bad. It could be that the alternator is bad. You don't really need to know cars to know this, though. But logically speaking, you couldn't a mechanic could not make this conclusion. Okay, so this is just kind of precursor to the next of the laws here. So let's look at the law of detachment. It says if a conditional is true and its hypothesis is true, then its conclusion is true. This is what we used in that first example with the garden. Okay, now they will use the arrow notation that we talked about in the last section. If P implies Q is true, right? So this is an if-then statement. This is like saying if P then Q. It's like saying if P then Q is true, true statement, and P is true. Okay, so the hypothesis is true, then Q is true. Okay, now let's take another example for that. More mathy example. If angle A is acute, then the measure of angle A is less than 90 degrees. Now I invented the word then there, but I would prefer to have that. If angle A is acute, then the measure of angle A is less than 90. True statement. And then they say angle A is acute. You can conclude that the measure of angle A is less than 90 degrees. Okay? Now, one thing, sometimes they'll be specific like this. It probably would be a better question if they just said an angle. If an angle is acute, then it is less than 90 degrees. And then they say angle A is acute, you can conclude that the specific angle A is less than 90 degrees. I hope that made sense. Okay, next example. Now, this is a good one. You got to think through this one now. A lot of students get this one wrong. Does the following argument illustrate the law of detachment? If you make a field goal in basketball, you score 2 points. Jenna scored 2 points in basketball. Break it down into its parts. You do not need to know basketball to answer this question. By the way, for the purpose of this question, let's forget about the 3-point line. Okay. Back when I played I think I was going into my 8th grade year was when we got the 3-point line. So there wasn't always a 3-point line. And just for the sake of this problem, let's pretend like there are no 3-point baskets. Okay. If you make a field goal in basketball, you score 2 points. Is like saying if hypothesis, then conclusion, right? And then you're told the conclusion. Jenna scored 2 points. You got a specific thing about this girl, Jenna, and Jenna did the conclusion. Now, again, many people who do understand basketball will say, well, there's another way that you can score 2 points. That would be to make 2 free throws. But rest assured, this is not a basketball question. You need to see this in its 4 parts. If, hypothesis, then conclusion. I wish they would have included the word then. Let me just add it. If you make a field goal in basketball, then you score 2 points. Jenna scored 2 points in basketball. You can conclude nothing about this. We don't know how she scored 2 points because you weren't given the hypothesis is true. You were given the conclusion. So you cannot, this is really a no conclusion situation. Okay. By the way, field goals are a thing in basketball. If you're thinking, field goals, football. No, I mean, when you make a basket, that's called a field goal. People who do know basketball will back me up on that. Okay. So no conclusion. A lot of people want to say, well, you make a field. A lot of people want to say, well, Jenna made a field goal, but actually that's not true because it doesn't match with the law of detachment. It doesn't fit. Let me give you another example. Look at quick check 3 right here. If a road is icy, then driving conditions are hazardous. Driving conditions are hazardous. You see, if a road is icy, then driving conditions are hazardous. This is a true statement. When roads are icy, it's a little rough outside. Maybe some of you drive already, and it's winter is a tougher time to drive. And then we say driving conditions are hazardous. Can you make a conclusion? Can you conclude that the roads are icy? If the basketball question was a little bit confusing to you, this one really ought to clear it up. You cannot conclude the roads are icy. There are other reasons why driving conditions would be hazardous. Driving conditions are hazardous when it's windy. Driving conditions are hazardous when it's raining really hard. There are many different reasons why driving conditions can be hazardous. The road surface could be messed up. You don't need to come up with all that stuff, though. What you need to see is if, hypothesis, then conclusion. And to be able to conclude anything else, you'd have to be told something about the hypothesis, but this is speaking of the conclusion. Driving conditions are hazardous. Okay. Now let's talk about the law of syllogism. It's a funny word, right? So I'm looking at this one now. There's 2 laws. We just covered the law of detachment. Now we're going to talk about the law of syllogism. And the law of syllogism uses the same kind of language here. If P implies Q and Q implies R are true statements, then P implies R is a true statement. Okay? So it's basically if A, then B, if B, then C, then you conclude that A, if A, then C. Okay? If sometimes we play the DirecTV commercials where they say, if you do this, then you do this. I'm trying to think of it. If your cable goes out, then you're bored. If you're bored, then you want some entertainment. They're funny commercials. Look it up on YouTube. That's an example of the law of syllogism. Okay. Don't sell your hair at a wig shop. Here's not as fun of an example, but it's the application of the law of syllogism. Okay, first of all, they made a mistake here, and they did not mean to put if in red. Remember that if is not part of the hypothesis. If you include it on a quiz or a test, I'm taking at least a half point off. That should have been black. Black, red, black, blue, black, green. Okay, and basically what we're going to conclude, since I'm already referencing the colors, is red implies green. Think about it though. If a quadrilateral is a square, then it contains 4 right angles. If a quadrilateral contains 4 right angles, then it is a rectangle. We can conclude if a quadrilateral, I'm going to abbreviate, is a square, then it is a rectangle. And that is a true statement. Okay, rectangles and squares are not mutually exclusive, but we'll get to that in chapter 6. Actually, we might be skipping that, but it's true. You could look forward into chapter 6, and the definition applies. A square is a subset of rectangles. Squares are subsets of rectangles. Okay, and one more thing. At the last, nope, sorry, 2 more things. If possible, state a conclusion using the law of syllogism. If not possible, okay, if a number ends in 0, then it ends in 10. If a number is divisible, if a number ends in 0, then it's divisible by 10. If a number is divisible by 10, then it is divisible by 5. True statements. Any number that ends in 0 is divisible by 10. Any number that is divisible by 10 would also be divisible by 5. So what we're going to do is put them together, and we're going to go if this, and I'm just going to, for time purposes, do that, then this. If a number ends in 0, then it is divisible by 5. True statement. Okay, last example. Put them all together now. If the circus is in town, then there are tents at the fairgrounds. If there are tents at the fairgrounds, then Paul is working as a night watchman. The circus is in town. Okay, so this is the most information you've been given in any example. First of all, take these two, and you can come to a conclusion. You can conclude a sentence that would say, if the circus is in town, then Paul is working as a night watchman. But this is not the end goal. This is not the last, I should say. This is an intermediate conclusion that we've come up with. If the circus is in town, then Paul is working as a night watchman, right? Just using the law of syllogism. Okay, but wait a minute. Then they gave us this last statement. The circus is in town. Well, look, the circus is in town is here. This is this hypothesis. If the circus is in town, then Paul is working as a night watchman. So our ultimate conclusion here is Paul is working as a night watchman. Sorry about my handwriting. It does get a little bit bad when I get to the low part of the screen. Okay, so you see that we use the law of detachment, we use the law of syllogism first and then the law of detachment to make this ultimate conclusion. We really didn't even need to include this. I just wanted to show you what I was using. Lastly, think about this last one here. The Volga River is in Europe. If a river is less than 2,300 miles long, it is not one of the world's 10 longest rivers. If a river is in Europe, then it is less than 2,300 miles long. Okay, I bring this up because this will happen in your homework. And basically, if it doesn't make sense to you, try reading them in a different order. This information was given to us in a different order than the Paul working as a night watchman at the circus example. Try reading them in a different order like this. If a river is in Europe, then it is less than 2,300 miles long. If a river is less than 2,300 miles long, it's not one of the world's 10 longest rivers. The Volga River is in Europe. Okay, so that would be arranged the way the last example was. And we could take the second and third sentence here and come up with a statement that says, if a river is in Europe, then it's not the longest, not one of the world's 10 longest rivers. And then the Volga is in Europe would suggest that the Volga is not one of the world's 10 longest rivers. Just simply write, the Volga River is not one of the world's 10 longest rivers. And I'm sorry the video got a little bit long, but it's an important topic, so I wanted to give it its right due time. Thanks for watching.